This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software. Developers, are you ready? It's time to upgrade your data platform to InterSystems Iris. Choose your language. Choose your tools. Choose your environment. Collaborate, build faster, and deploy more efficiently. When you can make faster decisions, there's no telling what you'll create. Ready, set, code. Start coding for free. Visit intersystems.com/try to try Iris.
Hey, this is Jeremy Jung for Software Engineering Radio. Today I'm speaking with Sara Leen. Sara is a localization programmer for Encoded games. She's also been working in the games industry for over 10 years. I'll be speaking with Sara about her experience translating games from Japanese to English, adding improvements to them, and porting them to different platforms. Sara, welcome to Software Engineering Radio.
Thank you for having me.
The first thing I want to start with is you have experience with building other types of software. I was kind of taking a look at your resume. What makes games different than working on a typical software application?
Well, in general, with games, there's a lot of things that you have to worry about that you otherwise wouldn't. Like the frame rate of the application becomes very important. For example, you need to make sure that the timers of the application are coded just so that the game will always run at a steady pace. And there are various applications of timers like delta time that are usually used to ensure this goes perfectly smooth.
And so when you talk about timers, I've heard of this concept of like a game loop. Is that kind of what you're referring to, or could you elaborate a little bit?
Well, essentially, a game, of course, is made of graphics, audio, and input, but all of these have to be checked every frame. And so you have your timer going so that it is basically looping through the game 60 times a second, or whatever other frame rate your game is running at. A lot run at 30. There will be various steps in this process, like game logic and drawing the various models. And of course, you have to keep the sound system updating.
So it's like, as opposed to, say, a web application where a lot of things are in response to something, right? Somebody going to a web page, clicking a button. With a game, it sounds like there is this sort of consistent loop, I guess, that's tied to the frame rate. Is that correct?
Right. And instead of reacting to things, you are occasionally checking the state, of course, so many times per frame. And you will still have to respond to the user input, but it's all going to be one part of this large set of functions.
If I understand correctly, so you're basically in this loop, and let's say somebody was pressing a button on their controller or moving their mouse, like that would affect the state. And when you're in that loop, it's going to look at that state to determine what to do next in the loop. Is that kind of the right idea?
Yes, exactly. For example, in your input system, you're usually going to be saving every frame the state of the input system at the moment. Like, is this button being pushed? Is this button being pushed? Was this button pushed last frame? And by comparing it against the previous frame, you know what the user is doing right now. And then many parts of the game logic will have various branches that check exactly what the user is inputting and what the current context is. It's certainly more complex than the idea of, I push a button and it calls this function.
That sounds like an entirely different model of thinking, I guess. I guess the structure of the application has to be almost completely different.
Absolutely.
In terms of skill sets on working on a game versus working on a regular application, what parts are really different and which parts are kind of the same?
Well, essentially, regardless of what you're working on, you're going to be working with a lot of external APIs, but these are probably going to be entirely different for a game versus other software. For example, you need to be familiar with APIs like DirectX and OpenGL, and all of these typically have different ways of handling graphics, handling audio, handling input. There's also SDL, of course, that you could use. And depending highly on the programming language as well, there may be different ways of handling certain things that would be different from handling a normal application. But most importantly, you need to be familiar with graphics and audio APIs above all, I think. I think those are typically less important when you're working on normal software, because you're more concerned about how to build your window and how to get all of the elements displaying in the proper positions.
I guess with a typical application, the actual act of rendering to the screen is sort of abstracted away from you, so you don't actually have to worry about how to draw to the screen. It's sort of more like, I just want a button or I just want a window, and something else is handling that for you.
Yes, that's pretty much it. And when it comes to video game graphics, you have to consider a lot of different things, like differences between graphics cards. Can this graphics card handle square textures, or does it need a different shape? As well, of course, as being concerned with the quality of how it's drawing. Like, is this texture supposed to be filtered? Will this graphics card filter it correctly? The APIs simplify that, but you're working at a lower level.
And when you were giving examples of APIs, you were talking about DirectX and OpenGL and SDL. How low a level are we talking? Like, if I wanted to draw something to the screen, kind of at the most base level, what kind of work am I looking at?
Well, for SDL in particular, this is somewhat of a simplified process because it handles all of the initialization of devices and such for you. But with DirectX and OpenGL, you have to actually get the list of devices. You have to initialize each process that you need. Like, you need direct 3D, you need direct input, you need direct sound. And then, you have to make sure that you have all of the device information that you need, including stuff like the current resolution or the capabilities of the device. Device capabilities is a big thing when it comes to that. And then to actually draw the image, you are going to need to create a texture buffer, you're going to need a back buffer for the screen, and then you will have to load the texture, and you will have to draw the texture to the buffer and then present that to the screen.
When you refer to the buffer, I just at kind of a high level, can you kind of explain what that's doing?
Well, essentially you have the screen that you're drawing to, and you usually don't want every single draw command to go directly to the screen. It's better to have a buffer that you can operate with so that you can display things in the correct order at all times. You can have them on the correct Z level. And of course, any sort of processing you need to do, you can do before it's drawn to the screen. And so everything goes onto the buffer after it's, ready, more or less.
And so when something is in the buffer, is that kind of like, that's what you plan to actually have the video card render, or is that like after it's already been rendered? Where is that in the stage?
Well, rendering is basically the last step of presentation, but it depends. If you are drawing something 3D, naturally you are going to have to do some processing on that via the graphics card, and the APIs allow for things like that. But typically, rendering to the screen itself is always going to be the very last step of the frame.
Okay. And then elsewhere in your application, you're deciding, even though you're putting things into the buffer, you're deciding that maybe there are certain frames that you don't actually need to render.
Yeah, and of course that depends highly on the game, but often there may be no difference, so you don't really need a new frame, or there might be a case where the game is overall running a little too slow, so skipping some of these frames will get you more CPU cycles free to work with.
Okay. We were talking about the loop earlier, where sort of all the logic is happening at a set rate, but in terms of the way people see the game, in terms of how smooth it is, you may have the game logic running at the same rate, but only choose to render certain frames in the buffer so it still runs the same. It's just that it's a little bit jerkier or choppier.
Yeah, and essentially you need your game logic working at the highest that your gameplay can really go.
Mm-hmm.
But when it comes to the graphics, it's a little more arbitrary for sure. There are situations where you might intentionally want your game logic running at 120 frames per second instead, and then the player input and such will still come at that speed regardless of the actual refresh rate of the display.
Interesting. I want to talk a little bit about how games can have a lot of binary assets. Typical software development, you would use Git as a version control system. Would you use the same for games, or is there a different system that's more suitable?
Well, naturally, this depends on the company. Quite a few do use Git and simply store the binary assets, even though there is no real comparison system for them. And as far as that goes, there are also various internal systems that companies may use that are specially made for handling their specific assets. And essentially, version control is not actually that different in the gaming industry. It just occasionally uses different applications.
Okay. And so when somebody uses Git, even with the binary assets, it's not an issue that you just can't see the diffs properly?
No, it's typically not a big deal because it's not difficult to look at two different pictures and visually compare them. And,
Right.
Generally you're going to be changing the binary assets less as development goes on rather than more. Whereas the
Right.
code, that's always going to be changing.
So the title you use is Localization Programmer. So what would you say is the main role of a localization programmer?
Well, essentially, when a game is being localized from one language to another, obviously the goal is that you get all of the text inserted and you make sure that it all looks correct. At base levels, this is generally the accepted position of a localization programmer. You are getting all of the text into the game. You are making all of the code work with the correct fonts and other asset changes that you may need that are different from the original language. However, there are a lot of things in this process that you wouldn't normally need as a skill. For example, if you are working with Japanese games, all of the comments and everything are going to be in Japanese, of course.
That kind of brings me to when you're translating games, do you usually have access to the original source code?
I usually do, but there are plenty of cases where we are working on a game and the original developer is actually the one to handle the localized version. It depends a lot on how much other companies feel they are able to release to other parties, whether it's because of rights issues or they're just kind of nervous about the code quality, which I mean, I would be.
And when you get access to the code, do you usually have access to the original developers, or are you kind of on your own?
I would say that that completely varies. You never know exactly, but it's usually going to be the same with each partner. Like, they will usually be more than happy to help you if they have the developers on hand to help you. But with game companies, of course, they are constantly developing new titles themselves. So when someone like me is working on a game, we may not have as much access to the developers, or they would be working on the game.
And so you were talking earlier about being able to extract text or bring text into the game. What are some examples of ways that the text would already be stored, and how would you bring that out?
This also varies a lot, and it's very interesting. Many games use script files, essentially lists of commands for their events, etc. And in these cases, as long as you know the format of the script file, you're usually going to be fine. But some games like to hard code their text, and yet others have them in binary formats that have been compiled in some way, assembled rather. And when that happens, you often have to take a look at the code and figure out exactly what this format is, which may or may not be documented, and basically do the process in reverse, unassemble it.
The first example you gave was script files, so would that just be like a plain text file, and you could go in and replace that text with, instead of Japanese, put in English?
Essentially, yes. Like when there's a script file format, you're going to see various commands like there will be message, and then it will have the text for a message box, that kind of thing. And when that is the case, it's usually pretty easy to change since it is just text, but you might run into some encoding issues.
By encoding issues, would that be where, let's say you replace the Japanese with English and then the game itself tries to load the text from the script file and it can't due to a different text encoding?
Not so much that as you might get garbled text. What in the fan community that I used to work in, we would call cave speak.
Could you kind of explain what you mean by that?
Imagine that you are playing a game in Japanese, but your system doesn't have Japanese fonts loaded. The font not being there for Japanese, you might instead see gibberish like EKVGH, that kind of thing.
Okay.
And that is cave speak. And if the encoding is very specific for the game, or the font simply doesn't have other symbols, you might get complete gibberish in what font was already there. In Japanese, it's called mojibake. The way that encodings work, of course, is that the text is interpreted from its binary or hexadecimal format into characters we can understand. And since there's a lot of different encodings out there, sometimes you don't know exactly what you're going to get. So, for example, if a game was made for an older system, it may have a completely custom encoding where a value like 2 means A. And in this situation, just replacing the text, you have no idea what the game's going to output. You're going to have to change it all yourself.
I see. So it's like in the original, I guess, text in the script files, or perhaps you're talking about the binary files, they're not necessarily using a standard encoding like, say, ASCII or Unicode. They may have made up their own encoding format.
Yes, and this certainly varies. When it comes to Japanese, you'll usually be able to find that it's in the standard Japanese encoding, Shift-JIS. And Shift-JIS largely supports English letters, but because Japanese text tends to include characters that are all the same width, it doesn't often account for the fact that in English, you have very thin letters like the letter I. And so when you simply insert the text into those games, you might get a situation where all of the letters are spaced really far from each other. And that does not look good.
Because the Japanese language, each character is the same width and height, but in English it varies, so that's why everything gets spaced out.
Right.
You were talking about how there's the example of script files or the example of code being hard-coded or maybe even binary files. Sort of what is the end result you'd like to get this text out for a translator to work on? What are you trying to give to them for them to work on?
Typically, the text you want to get into an Excel sheet because that's the industry standard for translation and keeping text like that. Sometimes the developer will provide this themselves, and that will, of course, make the process of translation a little easier because somebody like me can work while the game is being translated. But usually, it's more a case of what is the translator comfortable working with? Like, are they comfortable working with script files? Do they need an Excel sheet? Most of them do, and that's fine. But obviously, this results in more steps. You need to create a tool chain to both extract the text and get it into a sheet, and then you have to make the call of whether you can get that text directly back into the game, or if you would need to include more information like the exact lines it's from.
The simplest, I guess, would be the script file, where you might build a tool to convert the script files to rows in an Excel spreadsheet. A translator works on that to translate it to English. They give the spreadsheet back to you, and you run some kind of application to convert their spreadsheet back into the script files?
Yes, exactly. Although granted, if a game is very small, you might just do it all by hand.
Okay. In terms of these script files, are the lines of dialogue or the text, are they kind of in their original context? Like if somebody in a game was having a conversation, would all of the sentences kind of be grouped together, or is it sometimes just kind of spread all over the place?
This varies a lot. Sometimes you won't even know which character is speaking unless you actually play through the game while you're working on the script.
Wow.
And obviously, this poses some interesting challenges.
Mm-hmm.
Because in general, Japanese is not as context heavy and context apparent as English is. You can't always tell who's talking just by the tone of their voice, so to speak.
Going back to when you have something where the text is hard-coded, is that a case where you basically have to do it by hand, or have you found a process to deal with that?
There are a variety of ways that this can be approached too, which is part of the beauty of games. It's an art form. But what I personally like to do is simply make something that extracts all of the apparent strings, like surrounded by quotes, from all of the code and gives that information along with the line number. And so just like with any other script, you can usually automate this.
I see. So you basically create your own version of a script, I guess, even though they didn't exist originally.
Yeah, and then you have this list of all the strings in the game, and you can easily put those into a sheet.
Mm-hmm. When you work on localization, how much of the code base or the game engine do you feel like you need to understand?
It depends on the scope of the task, but typically, I would say that I don't need personally to understand much of the game to start working on it. But by the time that the project is finished, I should understand almost everything except for the raw graphics APIs being used. Even then, I might need to, depending on how the game is functioning and whether we need to do something differently, like making an older game use widescreen.
And what's kind of your strategy when, you first start work on a project, you get the source files, and you need to find out where the text is stored and how it's stored? Kind of what's your strategy for figuring that out?
First, I will look through all the files I received and make sure that the text isn't somewhere extremely obvious. And if it's inobvious, I will then start looking at the source code and getting it to compile. And I will look through that to see exactly what files it's loading. And from there, I can usually figure out where the text is stored.
In terms of when you get a project, do you just look at the code, or do you figure out like how to run it and all that first?
Well, usually I prefer to start by looking at the code itself and getting that to compile.
Mm-hmm.
But typically a developer will provide a working copy of the game that you can use to see exactly how everything functions. I do like to know what kind of game I'm working on and the basics of the gameplay, the basics of the setting, because that will help me motivate myself to work on it. It will help me get into the right mindset for it.
You were talking about how, there were kind of easier ways of localizing in terms of script files, and like maybe the hardest being hard coded or binary. What are some ways that if a developer is making a game, that they can facilitate like the easiest localization?
The easiest localization would definitely be first, you want to make script files for everything. Whether it's just the list of strings that the game is using or a proper script file for all the events. And then you want to make sure that the game is capable of loading different sets of these based on what language is currently in use. And if the game is already capable of loading different folders or different files for different versions of the scripts, then it shouldn't be too hard to localize. But you also need to make sure that there are easy ways to work with the graphics. And, of course, absolutely all of the assets can be loaded differently based on the language. Another problem, of course, is when it comes down to stuff like fonts. Because to make a very pretty looking font, you probably want to make the font graphical rather than using a TrueType or OpenType font. And, of course, the challenge with that is including every character you could need for every language. as well as issues like the font could be, badly spaced in certain languages. And to make a game as easy to localize as possible, you probably want to use Unicode and Unicode fonts and just include everything you possibly can.
And because Unicode has most, languages used in the world, so then you won't have the text encoding problem.
Exactly. You would completely skip that step. You wouldn't need to worry about the fonts. You would just be able to put whatever language you need, and you won't get tripped up by stuff like in Japanese games, Shift-JIS is the encoding used, right?
Mm-hmm.
And if you try to insert accents like an E with the little dash over it, it will instead draw a Japanese symbol if you don't change the encoding.
I see. You were talking about graphical fonts, so would that be like a raster image, like a giant PNG or a JPEG that has all the different characters on it? Is that kind of how that would work?
Yes, exactly. Usually this also has some sort of table containing the geometry of the font so that you can draw it with proper spacing and everything.
And then when you're talking about assets, that would be like textures. Like, for example, if you had a sign in the game, that would be something that somebody would actually have to go into, say, Photoshop or something and have a different version for each language.
Yes, and ideally you want to keep all of the original layered versions of this with the text on a separate layer, because that will make it as easy as possible to change the text that's on it. But of course, that isn't always available, so when it's not, you need somebody who's actually able to remove the text and put something new in. There's also things like title screens, of course, and any sort of special menu text you have, like that's drawn in a different font or has a special design.
Because I guess, something in Japanese versus something in English can look significantly different when you're doing a logo or something. So you need someone with the sort of artistic expertise to be able to recreate something that looked like the other thing, right?
Yes. And of course, Japanese logos are often written entirely in Japanese, so you will want to come up with a localized title for these games and then put it in the correct localized language. And that will involve basically designing a new logo that looks similar, gets the same point across, which is the big thing in localization. You want to get the point across.
One of the games you worked on was a game where you decided that the game's code needed to be rewritten. Can you kind of talk a little bit about what the game is and why you decided that you needed to rewrite the game?
Well, in this case, we are talking about a game called Corpse Party. Corpse Party's origins were as an RPG Maker game on an obscure Japanese computer, obscure over here at least. And when the developers revisited it many years later, they decided to remake it in a programming language called Hot Soup Processor, or HSP for short. And HSP was taught in many Japanese schools because it was free and it was made for people wanting to get into things like this. Now, Hot Soup Processor resembles basically the child of Java and C. And in this way, everything is a little different. I wouldn't even compare it to C, honestly, more like BASIC. And as a result, your game looks more like a scripting language than a programming language. And the bigger problem is that you don't have as much control over the graphics and sound APIs for games that are coded in HSP. And so to do many things with the graphics properly or get the timers right, it may be better to change over to something else, especially if you're going to put this game on something like Steam, because Steam does not have a version of their API for Hot Soup Processor. I know, shocking.
Calling all developers. There's no telling what you can create when you upgrade your data platform to InterSystems Iris. Are you ready to build the applications you want, however you want them? Are you ready to develop applications faster than ever? Collaborate, build faster, and deploy more efficiently. Tomorrow's next breakthroughs are waiting for you today. InterSystems Iris Data Platform. Ready, set, code. Start coding for free. Visit intersystems.com/try to try Iris.
when you're talking about it being like basic, is there kind of like a high reliance on like go-to statements, or just kind of curious what the language looks like?
Unfortunately, yes, there is.
Mm. Was this a statically typed? What was it like to kind of work in that language?
Well, when it comes to typing, you don't always know what type it's going to be. You don't know if this variable is necessarily an integer or if it's a float, and the compiler of the scripts largely doesn't care. And
Hmm.
obviously, that means you can run into some typing issues because you have completely misunderstood what a variable actually was. That definitely gave me some headaches.
So it's sort of more like, say, JavaScript or Ruby, where you can define a variable, and that variable you could put in a string, you could put in a number, you could put in pretty much anything. And there isn't really a way to check, I guess. It just kind of runs through the interpreter, and then you find out at runtime whether something's going to blow up.
Pretty much, pretty much. I definitely would compare it to Ruby in that regard.
So what was your strategy for rewriting a game? Like, were you porting function by function? Kind of how did you get started?
Of course, I started by just copying all of the code, and then I began rewriting each function one at a time, trying my best to understand the purposes of each function as I was going along. I knew what some of them did already because we actually inserted the translation before all of this, but the thing is that I was never going to be sure exactly what functions relied on each other and what variables were needed and how exactly they needed to be typed until everything was already basically put together. And so I honestly was pretty scared during this process at times because I had no idea if it was going to work until it worked.
Mm. You were rebuilding it function by function, but because it wasn't really clear which functions relied on other functions, you couldn't actually run the game. Like there wasn't like this iteration of you got part of it working and you can see it, and you move on to the next part. You had to almost build everything, and then you found out if there were issues.
Yes, exactly.
Mm.
Because for the most part with games, you are not building the code level by level. You are programming something that will be able to run all of the levels.
Wow, that sounds terrifying.
It is.
Were you able to sort of, at least on a function by function level, have an idea of what the function was supposed to return, and so you could at least test certain functions?
Yes, there were definitely cases like that. However, the most complex parts of the game are often more in the graphics and audio engines and such, if you're working at this kind of level. And I wasn't always sure how the graphics functions worked. No fault to the developers, just that it was so much.
And so, you know, since you didn't quite understand how the graphics functions worked, when you rewrote that portion of the game, did you kind of take a different approach rather than trying to recreate what they had done?
Well, I initially tried to recreate what they'd done, although for certain API functions, etc., I basically took my best guess. And so when the game was finally running, it definitely didn't look or sound right at first. There were
Hmm.
problems, and these were entirely problems with how I had understood the code rather than anything to do with the game itself, of course.
Hmm. How long did it take from sort of the start of getting the code to actually being able to run the game at all?
Well, the original version of the game pretty much worked out of the box, and compiling it, I just needed the version of the HSP tools that the game had been made for.
Hmm.
But when it came to actually making my version of the game ran, it took about a year.
Wow. So a year before you could launch the game.
Yeah,
Wow. That's
yeah.
that's pretty intense.
Believe me, I hated myself for a lot of that project.
Mm.
I was like, why didn't I just use the original code? Why did I put myself through this? But the result
Hmm.
was that the game runs very well.
Yeah, yeah. It's interesting because I think one of the sort of, I guess, common pieces of advice people get when they work on software is quick iteration in terms of build the thing, see if it works, then you can build the next thing. But in this case, it seems like that just straight up wasn't possible to do.
Yeah, unfortunately. With games, everything is going to be more tangled. And depending on the way you actually approached creating the game, you can end up with either something that's very clean and parts don't depend too much on each other, more abstracted, or it can
Hmm.
be a plate of spaghetti.
Right.
And just like any application, this is a matter of designing the application before you start building it.
Hmm. One of the things that you managed to do when you rewrote the game was, I believe you made it sort of platform agnostic. What are some examples of ways that when you write a game, you make it something that can be easily run on different platforms?
Regardless of the platform, you are going to be dealing with different graphics and audio APIs because, you're not going to run DirectX on a PS4. And essentially, the approach you need to take with this is mostly related to creating wrapper functions for all of the graphic stuff you need to do so that you can easily change these functions and not have to change any other part of the code. For example, you want to have functions for drawing a sprite. You want to have functions for drawing some text. And you want these to be things that you can easily change the contents of without changing any part of the actual game's code directly.
And I guess the parts that are going to be different from platform to platform, would you say that's like the graphics, the sound, the input, that sort of thing?
Yes, basically everything that deals with I/O, aside from the fact that on pretty much any platform you're going to be able to use like fopen without any issue.
Hmm. When you rewrote the game, I think you had said that when you got the original version of the game, you had replaced the text. Was that hard coded into the game, or was that through scripting files?
Mostly scripting files, but it took me quite a bit of effort to understand these scripting files. There definitely was some hard coded text in the game, mostly related to the menu functions, like chapter names, for example, that you would encounter in the menus were hard
Hmm.
coded.
And when you did the rewrite, did your rewrite load in the original script file format?
Yes, actually. Although, interestingly enough, with this particular game, all of the original scripts were in Japanese, like even the commands.
Hmm.
And this is not common. It does happen, but usually the commands and such will be roughly in English because when you're working with programming, you're going to be writing some of it in English no matter what language you speak.
Hmm.
But since all these scripts were completely in Japanese, I decided to replace all of the commands such that the game could still load the original format, but it was using something sort of new in that the script commands were simply translated.
And when you refer to like a script command, could you give an example of what some of those would be?
Well, stuff like message, wait, display picture, move
Mm.
character to the left, or, stuff
Hmm.
like that.
Hmm.
Or check a variable. It's a lot like programming. It's just that you are working in a language that is created for the game and is being used by the game without compilation usually. Sometimes
Mm.
there's assembly involved, but when you assemble a script like this, you are just converting the commands to 1, 2, 3, etc. to
Hmm.
make sure that you know what the commands are without having to use as much text and
Hmm.
space.
Okay, so it's kind of like a like an enum. Is that a good example?
Yeah, essentially.
And those commands, they would use the English letters, but they would just be written in Japanese words.
They were actually written in Shift JIS full Japanese.
Oh, wow.
I
Okay.
never encountered any other project that did that, although I understand it must have made the script files really easy to understand for them.
Yeah, it's kind of interesting how, we sort of make the assumption when we look at code that there's going to be English in it. But yeah, I guess sometimes you get surprised.
Yeah, for the most part, there aren't many programming languages where you can do everything in another language. But if you're
Hmm.
creating the language yourself, obviously you have plenty of control over that and you can do anything. And so, even though we sort of take for granted that there's going to be English, there doesn't have to be. And I find that extremely interesting.
I don't know that it happens very often, but I think a lot of languages do support Unicode for variable names and stuff like that. I just am not sure how many people actually take advantage of that.
Yeah, when it comes to seeing localized variable names in source that are not in the normal character set, I would say I hardly ever see it.
Mm-hmm.
I can only think of one occasion, and you will usually instead find that it is written in English characters but is in that language, which in the
Mm-hmm.
case of Japanese is what they call romaji. So you would have the Japanese written entirely in letters. And
Mm-hmm.
you find that a lot when you're localizing Japanese games.
Mm. You said kind of after the year you were able to run the game, but there were bugs or there were different issues. How were you able to sort of track down what bugs were in the game? I mean, was it a completely manual process where you just had to keep playing and keep trying things?
Essentially, as well as having testers within the company also handle that sort of testing, what is called, of course, quality assurance. Of course, we just call it QA. But by having people iterate through the game many times, we would find all of the bugs with it, essentially like you would any other program. You just have to have
Mm-hmm.
people using it.
Were there any kind of bugs or odd behavior in the original version that the game was relying on that you had to reproduce?
I wouldn't say there were any bugs that I had to reproduce, but since I had copied the game's code as closely as possible, some of the original bugs did carry over initially, and I was later able to fix a lot of them.
Cool. And we've kind of been talking about the process of making games and sort of rewriting games. Like, what is the language that you rewrote the game in?
C++. plus plus.
Is that pretty typical for the projects you work on that the games are written in C++?
I would say that the vast majority of professional games are written in C++. plus plus.
What would you say makes that sort of the default choice or the main choice that people would go to?
Frankly, it is widely supported. You have C++ plus plus compilers for consoles, you have them for computers, you have them for all kinds of different devices. Whereas you create a game in Ruby, you have no idea if you're going to be able to put that on a PlayStation 4.
Mm-hmm. So it's kind of just the fact that everybody's using it and there's so many tools, so much support.
Yeah, exactly. As well as the fairly robust standard libraries.
Mm-hmm.
And since these are available on so many platforms, it's just always been the choice ever since it came to be. Originally, back in the days of the Nintendo Entertainment System, games were primarily written in raw assembly. But obviously, that's not very practical, especially for the scale of games these days.
Mm-hmm.
So it eventually changed to C and then C++. There have been efforts to adopt C# in more platforms, but it's kind of slow going because it's just so deep rooted.
Yeah, I think typically when I hear about C# in games, it's within the context of, say, the Unity engine. And it seems like that would make it easier for people to sort of get started and work on projects, but I don't know what the trade-offs are, relative to C++.
Typically, I would say that C++ simply is the most easy to optimize compared to other options like this
Mm-hmm.
because of the nature of how it's compiled. Whereas with C#, they take a more native approach where all of the code is, it's native code and managed code.
Mm-hmm.
And the native code is easier to optimize, whereas the managed code that makes up most of C#
Mm-hmm.
simply isn't something you can optimize much beyond how it's handled for everything. It's a global optimization.
Mm-hmm.
Whereas optimization specific to various functions and games are better than global optimization in a case like this. The trade off is simply performance, how much you can pull out of the system before it starts choking.
Mm-hmm. And one of the big differences between the two languages is that C# has a garbage collector. For games, is that something that's typically seen as not desirable?
Rather than having garbage collection, you need to handle all of the game's memory very, very strictly. You need to know exactly how much memory everything is going to take at any given time. The reason for this is because consoles typically have much more severe memory limitations than a computer does. And if you start running over that memory, you just don't have a program running anymore. It's
Mm-hmm.
problematic. Whereas on PC, there are, of course, things like virtual memory to pick up if you end up running out of memory somehow. And as a result, if you have any sort of garbage collection, you're going to be wanting to do it yourself. Frankly, all memory that you're locating, you should be doing yourself. You should have your own memory manager in the game.
I see. And then you said like it's probably true for all platforms, but on consoles it's more important just because of the memory restrictions.
Yes. And of course, that is also why when you are porting a game to a console, you have to be very considerate of things like memory space and, of course, video RAM. It was more important back in the older days of systems like the Super Nintendo, the Nintendo 64, but it still remains important today. If you start running out of memory on a console, there's nothing you can do about it.
Mm-hmm. You've ported some games from low spec hardware like the PlayStation Portable to the PC. What are some of the unique challenges related to porting a game?
Well, first of all, when it comes to a game on an older system or a weaker system, such as the PlayStation Portable, the game is made exactly for the hardware specifications, and you are at the mercy of those specifications at first. For example, the PlayStation Portable, its resolution is quite small. It is something like 480 by 272. And while that is almost 16:9, it's not quite. When it comes to PC games, people want options. They want the ability to use different resolutions and customize their controls, and the original game is probably not going to have supported this. And more importantly, if you're working at a game at a low resolution like that, that is not going to look good on a PC screen. So we actually, with these projects, we take as many of the original PSD assets and such as we can and just redo the game's assets in HD. And that obviously results in a much prettier game, but that also assumes that you actually made the assets in higher resolution to begin with. Otherwise, they're going to have to be remade, and that is a whole different ballpark of problems.
Yeah, the resolution is so low that if you were to use the original assets, they would just look super blurry or blocky if you were to port it straight to the PC.
Exactly right, and frankly, that would make the game look a lot worse as a whole, and less people would play it. Because at that point, you're just playing something that looks old. And you don't want it to look old because you're creating a new version of it. You want it to look new and shiny and sparkly.
How would you say the process of porting a game differs from your experience, say, rewriting the game with Corpse Party? How much of it is a rewrite versus something different?
Well, when you're porting a game, hopefully it's in a language that you can still use. And if that's the case, then the first step is more going to be ripping out all of the stuff that you can't use. For example, when you're working on a console, you have to use the console developer's development kit and everything. You have to use their software. And while usually this supports the same programming languages that you would be able to use on PC anyway, you won't be able to use most of the graphics functions and the audio functions, and you're just going to have to do all of that over instead of copying like I did when I was porting one language to another. I instead had to basically take guesses at what all of these functions did and then reproduce them to my best. And occasionally this would result in something I didn't understand, just like when I was working on the original Corpse Party game. But more often, I would find that I missed a functionality and that something wouldn't change color when it was supposed to, or something wouldn't play from the correct speaker, or things like that. And one of the latest issues that I got when I was working on my first ports, like last minute, was that I realized there were audio files that were supposed to be looping and crossfading, and I had forgotten to implement any of this because I didn't realize what it was. And so when it comes to porting to PC, there are two main concerns. One is making sure all the functionality is correct in the first place, and the second is making sure that the game runs well on a PC. Because there are different threading models and different sorts of timer models that simply don't convert well to a PC. And that's the case with changing platforms in general. You want to make sure that everything runs as it should, even though it's on a different platform. Which, I know I'm just speaking in circles there, but at the same time, you have to realize if you just put a game directly on PC and you don't change anything, it is going to run a lot slower than it could because it was optimized for something else.
And when you talk about the different threading models, could you give an example of, something running on a console versus on a PC? What are these different threading models or different choices you would be looking at?
Well, for example, let's say that you are programming a game that is working on a Nintendo Wii. You will find that you have to handle the graphics at this time and the audio at this time, and threading is often a better choice when it's available for simple performance reasons. However, it's also the case that a lot of older games don't use any sort of threads at all. Everything is just a single thread going through that single game loop, and you have to deal with the results as they come. But when it comes to a PC game, you of course want threads. You want to be able to use more of the CPUs. And instead of using the exact CPU number and types that you have on the console, like that you have this audio and this CPU and this console happens to have a dedicated audio processor, stuff like that, you want to use something more general on a PC that'll work on anything.
Yeah, so in terms of, I guess, concurrency models on a console, the software development kit for that console may already have sort of ways that you're required to do certain things, like you were saying, a certain way to do graphics, a certain way to do audio. And once you bring it to PC, then you have more control over how you do concurrency, how you do graphics, and so you may choose to do it completely differently than how it originally worked.
Yes, and I think in many cases that's preferable, because obviously concurrency in something like a game is best used for optimization and making sure that everything runs smoothly without any hitches. But on a console, you are optimizing to such a specific scenario that this optimization does not carry over well and is actually harmful when you are copying it directly to a PC.
Are there any specific APIs, for example, OpenGL, that you would choose when you want to make something that you can consistently use across platforms?
I would choose OpenGL or possibly SDL because surprisingly, SDL exists for quite a lot of platforms. That said, I would say that Vulkan is becoming something that would be very useful in that sort of way.
In terms of the projects that you've worked on, the example you gave with PlayStation Portable, were those games using some kind of API specific to the console to do graphics rendering, to do audio, all that sort of thing?
Yes, the APIs for these things are typically provided by the development kit, and whether they resemble an existing API or not is pretty much up to the console creator's choice. For example, if you're working on a Nintendo 3DS, you can probably use OpenGL straight up with just a few changes, although the optimization is still going to be a nightmare by comparison, because it is completely different.
When you're working on one of these ports, have you ever kind of had to go the other way around where you had a less constrained environment and then had to move it to a more constrained environment?
So far, I would say no, because for the most part, PC is about the least constrained you'll get.
Mm-hmm.
But I still try to make sure that when I'm working on a game, it will run on as many systems as possible, and that means trying to make it run on a toaster if I could.
Mm-hmm.
And when your PC is a potato, you don't really expect a fully 3D game to work right, but sometimes they can. Sometimes, if you are very careful about the way you optimize the game, and do take a lot of constraints in what you're doing, you will make a game that looks a lot better than it should on an older PC. And I try to make that a goal of mine. I try to make sure that these games run in older environments. Up until last year, I was even making a point of supporting Windows XP with all of my games, and that would be more of an issue at times than you would think.
What's an example of something that you would have to do specifically for such an old operating system?
For supporting old operating systems, you essentially are limited when it comes to your compilers and your libraries. You can't use newer versions of libraries because they weren't made for older systems. The Windows kernel changed very dramatically with Windows Vista, and it's only been evolving more and more since. And you are limited to using this older version of the kernel that is largely still supported. But there's often behaviors that are just a little different between a system, and you won't expect them. Like, you might be trying to get the size of your window rectangle, and it will be off by 1. Small things like that. Or you'll be drawing text, and Vista might support outlining the text, and XP might not.
So there's like subtle bugs or small features that just don't exist. So when you have to take into account, whether you'll have those or not, it just makes everything more complicated.
Yes, exactly. And you don't always have the ability to expect it because often the functions will look the same, but the behavior is simply different.
And these are operating system level calls that you're referring to?
Yes, largely, although there's also the matter of APIs for things like graphics that don't exist on older operating systems. For example, you can't use DirectX 10 or later on XP.
One of the things about porting, as we were talking about, the things that you can't really reuse, is the core game loop and the logic. Is most of that, are you able to use as is without modification?
Well, for the most part, most of the game code is going to stay intact like that. You will have to alter stuff like the coordinate calls for various textures because all of a sudden you're worried about different resolutions. Games running on consoles, they generally run on a single resolution that is their target, and if you are using a different resolution on your TV, the console is scaling the output to that. But when you are working on PC, you need to account for that, and you need to account for different aspect ratios. Because while it's easy to say, oh, I'm going to make my game this resolution, you might upset the people who have ultra-wide monitors, or the people who are still using old 4:3 monitors. They exist. And ideally, you want to support all of these scenarios as smoothly as you can. When you're creating a game, you can account for this better than if you're working on a game that already exists.
Yeah, so it sounds like just a lot of work in general in terms of finding the sections of code that are expecting a specific resolution, a specific aspect ratio, and like earlier you were talking about how your assets may change as well because you need UI elements that can be rendered at a much higher resolution or at a different sort of shape. So it seems like there's a lot of work that needs to go into it.
Yes, a lot of the games that I worked on earlier in my career were older games that were made for 4.3, and in the process of working on these, I realized obviously these games need to be widescreen. And so there were a lot of different approaches that could be taken. I could have converted the entire games to widescreen, but then what about the purists? So I made this approach where I could arbitrarily in the code set any graphic to be aligned to the left or right of the screen or the center, essentially by dividing the screen into regions that were still 4:3. So, for example, I would draw a UI element that was always in the bottom right of the screen on the right, and when the aspect ratio increases, this would still be drawn on the right of the screen in the corner. And by separating out HUD elements like this, it gives a fairly consistent experience between different platforms without having to limit the user to a specific aspect ratio.
You've worked on a lot of different games that have been made at a long time ago or more recently. What are some of the big differences code-wise, I guess, you've seen in like the oldest projects you've worked on versus the newer ones?
Well, I actually got my start in fan translation, working on things in assembly, disassembly rather. And obviously the challenges for that are very apparent. You're working with very raw code that you don't have any information on. But as I've gone along, I worked on various Japanese indie games as well as Japanese professional titles. And as the time has gone along, I feel that on average, these games are more abstracted and more object-oriented. And back then, there was very little object orientation. There were just these loops, and loops upon loops. Nowadays, you'll have various objects that might be inherited from other objects. So a video game's character might be a single generic object that has most of the basic behaviors. And then on top of that, you will have the class for the player character or the class for a dragon. And they have their own unique stuff to them. And obviously, the game loop has changed a lot over the years as a result of things like this.
Yeah, it's interesting because I think that, I guess, matches how software development in general has maybe evolved, because there used to be, primarily just procedural code, right? And now we're seeing more object-oriented code, more code related to functional programming, and so maybe that parallels the general software community.
Yes, I believe so. In this regard, the evolution does seem pretty parallel. The only limiting factor is that adoption of new programming languages is very slow.
Yeah, I'm not even sure what they would have used before C++.
C.
Oh, right. Okay.
But before that, they really did just program games in basic assembly and occasionally in BASIC.
Yeah. And you were mentioning how, you had actually worked on fan translations where you would have to reverse engineer the code. And you said that was with assembly?
Yes, because when it comes to these games that are already compiled and you're working on them as a fan, you're not going to have any access to the source code ever. So there are two options available to you from there. You can either learn how to work with the code that's already compiled by learning the assembly and learning how to debug this, or you can, in some cases, to an extent, decompile the code if it was made in an existing framework that's well understood, like .NET or some other programming languages that exist. But usually you're going to be working with the raw assembly when you're working as a fan, and you need a strong understanding of the processor that the game was developed for and the exact sort of quirks to expect.
Yeah, so when you're working, as a fan, you actually somehow have to determine, I guess, where the text is in that game, right? Even though everything is just raw assembly. So what is kind of the approach for doing that? How would you even know where to start?
Well, initially you would have a debugger that works with the game, and you would have to step through step by step until you actually see the text being drawn. And then you basically start stepping back from there to see how the text was loaded. And so it's all a process of finding first something that uses the function you need to edit, and then working your way back.
Yeah, that sounds very, very time consuming, I guess.
It absolutely is, but it's an interesting process because you learn a lot about how different styles are used in different things.
Because then not only would you have to find the text, but you would have to find a way to reinsert it without, the application breaking.
Yeah, and in some cases the text would be stored in the application itself, but usually it's going to be in some sort of container you don't have any specifications for, and then it might be in some encoding you don't know. It might even be encrypted. And obviously all of the functions for you to fix that are right there, but how do you put it back in? Because it's easier to extract something than it is to create an archive that works exactly as the one before.
Yeah, that's interesting because like you said, you have these files where you don't know kind of how they're encoded, but you're looking through the assembly code to maybe get a hint for how they were generated so you can modify or generate them yourself.
Exactly. And when it comes to compressions and encryptions, it definitely is much easier to get a file that's already encrypted or encoded or compressed open than it is to make a new one, because You have to worry about the size of the file. You have to worry about getting the optimization of the compression right. You mess up one part of the encryption key and everything's wrong.
That sounds like pretty intense work for a fan project.
Yeah, I actually got my start working on just simple script engines in games like Furcadia, of all things, when I was young. But as it went along, I discovered things like emulation and all these interesting games in a language I didn't understand. And
Hmm.
all I could think was, how could these games be English? Is there a way? And
Hmm.
sure enough, there actually was.
Yeah, that's really really impressive and very cool. That kind of brings me to, for somebody who's interested in, modifying or localizing games, how would you recommend someone today sort of get started?
Well, I would find a project that you like on something like GitHub and simply try changing things and improving things in that first. Make it your own. Essentially, with something like this, you need to get comfortable working in other people's code. It's not about learning to program a program yourself, it's about learning to be comfortable in other shoes and being able to cope with the decisions they make.
Hmm. Yeah, that's a really interesting perspective because I feel like general software development, a lot of it is also that, right? Because so many of the projects people work on, they're not brand new. They're something that, a team has been working on for years, and you're kind of coming into that environment, living with the decisions that were made and figuring out where to go from there.
Yes. With normal game development, you'll find all sorts of tutorials that teach you how to build a basic platforming game engine or such, but it won't necessarily tell you why it's built that way. And you
Hmm.
can make games that way, but you can't really work with somebody else's games from tutorials like that. It
Got
has
it.
to all be about putting in the footwork yourself and just trying. You just have
Hmm.
to try, and you just have to keep doing it until it gets right, just like any other skill.
For sure. After all the years of experience you've had, are there certain things that you do really differently now than what you did before?
Well, definitely. For one, I used to do absolutely everything by hand. When it comes to even stuff like text, I used to copy the text and paste it into files as I needed it and rinse and repeat. And
Hmm.
when I was working as a fan translator, sometimes early on, I would change the pointers for the text manually when I needed more space. And that is just an awful idea. Automate as much as you can. Make sure that whatever you're doing it the easiest way you can. But at the same time, don't sacrifice quality for this. But typically you won't.
Hmm. So basically, like, find the things, I guess, that you are doing that are sort of repetitive. Try and identify the things that you can automate and build that script or build whatever functionality you need.
Yes, exactly. Because if you're spending a lot of time pulling the text out or something like that, you obviously don't need to be. There
Hmm.
are cases where you might want to do that, like if there's exactly one or two hard coded strings or just a single menu. But if the project you're working is at any sort of scale that makes that an hours long job, do not do it manually, please.
For sure. Yeah, I think that applies broadly as well. It's kind of like, how much pain do you need to feel before it's like, just get it done. Just automate it. Write that script.
Yes, exactly. The beauty of being a programmer is you shouldn't need to do much math because you can make the program do it for you.
Cool. So I think it's a good place to kind of start wrapping up, but is there anything else that you thought we should have mentioned or talked about?
Hmm. I suppose another thing I would like to mention is if you're getting into localization programming for a specific language, like Japanese to English or something like that, you should probably try to learn as much of the language as you can along the way. So, not just the programming language, but the actual language as well. If you are working on Japanese games a lot, knowing Japanese makes your work so much easier.
What are some of the ways that you found that knowing the language really helped you a lot?
Well, put simply, even though all of the text for a programming language is just going to be, in like ASCII, you're going to be dealing with the fact that all of the comments are going to be in another language. A lot of the function names are going to be in another language. You're going to see a file named Zako, and you're not going to know that that means a small fry enemy.
Yeah, so just helping you get as many, I guess, hints and context as you can. Yeah.
Exactly. Because when you're working on someone else's code in another language, you are not going to be working with documentation you can necessarily read. All of the documentation is absolutely going to be in that language.
Yeah, for sure. I guess code comments as well, if those exist.
They do, usually.
Cool. For people who are kind of interested in checking out what you're working on or what you're up to, how can they follow you?
First of all, obviously, you should keep up with Xseed's work in general if you want to keep up with what I'm doing. But I also have Twitter, Sara J. Leen, SaraJLeen. And I also occasionally do Twitch streams, not of programming, but of games in general. And my Twitch username is SaraLene, sort of a corruption of my name.
You work in a very unique field of software development, and I really enjoyed the conversation. Sara, thank you so much for sharing your experience translating and porting games.
Thank you for giving me a chance to talk about the technical side of things.
Yeah, it was really fun, so thanks again for coming on the show.
My pleasure.
This is Jeremy Jung for Software Engineering Radio. Thanks for listening.
Developers, take your marks. It's time to upgrade your data platform to InterSystems Iris. It's time to deliver complex mission-critical applications in the fastest route possible. It's time to use any data from any source. It's time to embed analytics and create interactive user interfaces. So what are you waiting for? Choose your language, choose your tools, choose your environment. Collaborate, build faster, and deploy more efficiently. Done and done. Tomorrow's next breakthroughs are waiting for you today. InterSystems Iris Data Platform, the fastest way to build applications. Ready, set, code. Start coding for free. Visit intersystems.com/try to try Iris. Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.